Today we are diving into something super cool, that is building a retrieval-augmented generation, in short RAG system, right here in Google Colab for free of cost. Google Colab is free, cloud-based notebook where we write and run Python code right into our browser. We don't need to install or set up anything. Just open a notebook, write a code, and click on Run button. In Colab, everything happens in a cell. We type our Python code into a cell and hit play button. The code then runs on Google server. We can run cells one by one, experiment quickly, and see output instantly, which is perfect for data science and AI learning. Colab gives us free access to one CPU, that is Central Processing Unit, one GPU, which is Graphic Processing Unit, a super fast multitasker, and one TPU, a Tensor Processing Unit built for massive parallel math operation. To access this setting, click on Connect drop-down in top right corner. We have couple of options here for hardware accelerator. We have CPU, we have GPU, and TPU. We can select different run types like Python 3, R, and Julia. For today's demo, we will use Python 3. In just few clicks, we can switch our runtime to GPU and speed up deep learning, model training, and heavy computations without needing a powerful laptop. Colab connects seamlessly with our Google Drive, loads the datasets from Drive, and keep everything synced in the cloud. That means our work is always backed up and accessible from anywhere. In short, Google Colab is our free cloud-powered coding lab with Python, GPU, Drive integration, and easy sharing all in one place. It is perfect for AI experiments, data projects, and interactive tutorials. First thing first, let's set up our environment. Go to GitHub and download Ollama RAG 5.3 notebook from my repository. Then log into colab.research.google.com with your Google account and open above file. This notebook contains the full RAG pipeline in just 4 steps. Next, click on the connect button and access T4 GPU and wait for confirmation to get it assigned. Then run the first cell to download Ollama and FAISS CPU. This code updates the Linux packages and install ZSTD, a compression tool required by Ollama for handling model files. This code downloads and install Ollama inside the Google Colab environment and install the Python libraries needed for the RAG pipeline. FAISS CPU for vector search, pandas for data handling, numpy for numerical operations, and request for API calls. Once this is successfully installed, FAISS CPU, we move to next step, that is to run the second cell. This code will load Python libraries needed for networking, timing, vector search, and JSON handling. This launches the Ollama server in the background, repeatedly checks if Ollama is responding on port 11434, download the 5.3 model using Ollama pool 5.3, gives Ollama extra time to load the models into memory. Once the Ollama is started, we move to next step to run the third cell. This code will define the function Ollama embed that sends text to Ollama API and returns 5.3 embedding, and then builds a FAISS index using this embedding for fast vector search. We have used sample data provided by Colab for this demo. This is available in the sample data folder inside content folder. We can also use our own datasets by uploading files in this folder. Once the index is ready, we move to next step, that is to run fourth cell. This code converts the user query into embeddings using Ollama embed, searches the index to find the closest matching document vectors, combines those documents into context block, and send the prompt to 5.3 model to return the model's final answer. That's it. We have built our RAG system in just 4 steps. Let's see it in action. I asked, what is the relationship between income and house value in these locations? And look at that. Our Phi3 model, powered by the context we provided, gives us a detailed, accurate response about correlation between income and house values. Now I ask, what is Oracle? And it gives me context is not present. This is because we didn't add the switch to look in LLM directly if context is not found. I give you the small challenge at this point to add that switch. Are you up for the challenge? Tell me in comments your result. In just few lines of Python, we built a powerful RAG system. Set up Ollama to run LLM locally, download and use models like Phi3, create and search FAISS indexes for information retrieval, combine retrieval and generation for LLM responses. That's all from me, and I'll see you in the next one.